at question 3 from July 2021, paper 2, CXC exams. All right, so question 3. So here it goes. It reads, the diagram below shows the triangle PQR in which angle QPR is 62 degrees and PQR equals 90 degrees. PR equal 11. So there it is, the information that we just read is right there. So let us see the questions that they're asking us to do. The first question says that they want to calculate, the size of angle PRQ. PRQ. I normally say mark the angle so that we see exactly where we're dealing with. So we want to find this angle right here, right here. This is the angle that we want to find right there. All right, so we want to find the angle shaded right here, PRQ. Now, when you look at this angle though, there is a quick one step you could use because this is the third angle in the triangle, right? And a triangle, the total interior angle of a triangle is 180 degrees. So then what we're saying is to find this angle, we're going to say 180 minus the sum of the 62 degrees plus the 90 degrees. So we want to summarize those, sum them up, right? And then take it from 180 degrees, and then we would have gotten that angle. So the answer is going to be 28. All right, so let me just write this final thing. And then we would have gotten 28 degrees for this angle right there. So the angle there is 28 degrees, right? Now the next question says the length of the side RQ. So we want to find the length of RQ. So we could put the length to the side here. RQ. We want to find the length of RQ. So let me identify the side that we identify. We want to find this side, RQ. Now, when we observe this side, we have many options, so I could just take one. So I'm just going to take 62 and said it's the opposite side to 62, and I have the hypotenuse side here. All right, I could take it from that angle. Somebody else might use 28 and said it's the adjacent to 28 and the hypotenuse. So depending on how you want to look at it, I'm just going to work out one way. So I'm going to use sine since I'm using the 62 degrees. So the sine of the 62 degrees is equal to the opposite side, which is RQ over 11. All right, which is the hypotenuse. So that's what we have. And then from this, you could see that if we multiply, yeah, if we multiply 11 by both sides, then RQ is equal to 11 times the sine of 62. So make sure our calculator is in degrees as we do this. 11 times the sine of 62. And the answer that we're getting right now is 9.71 centimeters, and that is equal to RQ. So 9.71 cm. All right, equal to that. All right, so we got that 9.71 cm. All right, so here we have a transformation question. So it says the diagram below shows 3 triangles, X, Y, and Z on a grid. So we're looking at our triangles there. We're looking at X, Y, and Z on the grid. All right, so there we have it, the 3 triangles. All right. All right, so let's see the questions that they're asking. All right, so we're gonna have to probably go back and forth. The first question says triangle X is mapped onto triangle Y by a reflection. All right, state the equation of the mirror line. All right, so triangle X is mapped onto triangle Y by by a reflection. So we were told that it's a reflection, and they're saying, all right, could you tell us the mirror line? Remember though, that the mirror line is gonna be halfway in terms of distance between any two corresponding points. So I'm going to color code my points that are corresponding. So we want to say this point corresponds with that point there. So I'm color coding the corresponding points. This point here corresponds with this point there. And lastly, this point here corresponds with that point. So we're suggesting that they are equal in distances apart, those corresponding points. So then we want to just look. And if you look, you'll realize that this mirror right now, the mirror that I'm looking at, the mirror is the x-axis. Look at it. This is the mirror right now. So the x-axis is actually the mirror line. We're looking at it, we're saying, yeah, the x-axis is the mirror line. So you could do a quick verification, just a quick count. So I could just say, look at this. No, this point here is actually 2 units on top of the mirror line. Therefore, it's expected to land 2 units beneath that mirror line, and we're seeing that being accurately done. Let's pick on this point here. It is 1, 2, 3, 4 units on top of the mirror line. So it is expected to fall 1, 2, 3, 4 units beneath, and that is exactly what happened. Then lastly, this point here, all right, it was 1, 2 units on top of the mirror line. So we expect it to fall 1, 2 units beneath or below. So yes, you could see it's a reflection, and not only that, the mirror line is the x-axis. So the x-axis is our mirror line. So here is our mirror line. This is my mirror. All right, this is my mirror. All right, so the mirror can be called y equals 0, or you can call it the x-axis. Right, so that's the mirror line right there. So let us just respond to this question here. So the mirror line is y equals 0, or we could say the x-axis. So there it is, just for one more. It says now describe fully the transformation which maps triangle x, onto triangle z. All right, so we want to describe fully the transformation which maps x onto z. So let us go back and look at it. X onto z, this one. So we want to pay attention to which maps triangle x onto triangle z. So there it is. So this is triangle x here. Let me just highlight my triangle x. So this is my triangle x, and this is my triangle z. All right, so we're saying then what transformation maps this onto that. We wanna carefully look at what's going on. All right. So one of the things that I noticed is that, so this is a rotation in an anti-clockwise direction, and it looks 90 degrees about the center 0, 0. So when you look at it, you kind of start to see things, but be advised that whenever we have a 90 degrees or 270, I'll just focus on the 90 degrees rotation, all our horizontal lines, the corresponding point line will be vertical. So I'm seeing that, you understand? So my horizontal line there became vertical. So that is something that we need to make a note of with every single 90 degree in any direction that occurs when we rotate. All right, so it is a rotation. But what I could do, Joe, is just to connect up just to show you the 90 degree. So we could just take out quickly, could just use this just to show the quick. So if I connect any two corresponding points, all right, to the center. So if I connect, let us say this point here to the center. If I connect that point to the center, let me use red. All right, so if I connect that point to the center, yeah. All right, so I connect that point to the center, and then I connect its corresponding point, which would have been this one here. And if I connect that to that center, you should see a 90 degrees coming out. Let's take a look at it. Let's take a look at that. And then we are seeing, so I just randomly connect those two corresponding points, and we are seeing the 90 degree coming out. So this is a thing that is showing us that it really rotated about 90 degrees. See the 90 degree there? That is it. So we definitely see that 90 degree coming out. And then it was going from here, you could see going across there. So that's an anti-clockwise rotation. All right. And then we're seeing that this is the center of the rotation right there. All right. So we want to respond to the question like that. So let us just answer this question, answer this question. So it is a 90 degrees anti-clockwise rotation about the center 0, 0. And that's 3 marks right there to do that. All right, so the next question says that on the diagram on page 10, which is with the image and with X, Y, and Z triangle there, it says translate triangle Y using the vector -7, 1, and then we're going to label that V, all right? So translate it -7, 1, then we're going to label that V, all right? Translate triangle Y using the vector -7, 1, and label this image V. All right, so triangle Y, -7, 1. So this is triangle Y that we're looking at here. Our triangle Y is this, and we want to translate that triangle -7, 1, all right? So -7, 1. -7 would mean that we're going to the left, and 1 means that we're going to go up. So the translation we're going to be using is t equal to -7, 1. All right. Remember though, the concept of the translation is that the top number, if it is negative, you go to the left. The bottom, and if it is positive, you go to the right. For the bottom number, if it is negative, you go down. And if it is positive, you go up. So in this case, we're going to shift to the left and then shift up. So we're going to take those, that's the sort of movement based on the numbers. Then let's move the points one at a time. So this point here will move 7 to the left and then 1 up. So we're going 1, 2, 3, 4, 5, 6, 7, and then 1 up. So it landed here. This point here is going to move 7 to the left, then 1 up. So let's go 1, 2, 3, 4, 5, 6, 7, and then 1 up. So it lands here. This point here will move 7 to the left and then 1 up, the same. 1, 2, 3, 4, 5, 6, 7, and then 1 up here. And then all we're going to do is just to recreate. So we're going to recreate that diagram. So from there to there. All right, so we recreate. All right, so there it is. Be simple, recreate diagram, and let me take off these markings now. That was just for instructional purposes. So there it is. And then it's a call it V. So we want to call this V. All right, good. So we translate it. So the entire thing would have shifted 7 to the left and 1 up. All right, so we're looking at that new image called V right there. So that's that. Let us see the next question. Next question says, it says here, it says on the diagram, so on the same page that we were just on, we want to enlarge x. So we're going to enlarge x about the center 0, 0. We're going to enlarge x about the center 0, 0 with a scale factor of a half, and then we're going to call it w, and we're done. So x, scale factor a half, we're on 0, 0. So we want to find x. So let us quickly clear up all of those things that were on x. All right, so I want to take off some stuff that we had on here. All right, good. All right, so we're gonna enlarge x right here. We're gonna enlarge x with a scale factor of, so let's write down what we have. So the scale factor we're using is a half. Since a dilation, it's gonna be reduced. So the scale factor is a half and the center is 0, 0. One of the things I want us to realize, I want to say to us is whenever you are enlarging with the center 0, 0, you can manipulate your coordinates and then recreate. All right. So because we're at 0, 0, we could manipulate the coordinates. In other words, then this is 0, 2. This coordinate here is 4, 4. And this coordinate here is 6, 2. We can manipulate this. The scale factor is a half because the center is 0, 0 right here. Then we can just easily find half of all the values of our coordinates and then recreate, and we're done. So a half of this is 0, 1. So 0, 1 is going to be the image for W, and this is going to be 2, 2, and this one is going to produce 3, 1. So because the scale factor is a half and we're at the center 0, 0, we could halve the coordinates. So 0, 1 will be a point right here. Let me use another marker. So 0, 1 is going to be right here. All right. And then 2, 2 is going to be right here. And then 3, 1. Remember, this is 1. This is 3. 3, 1 is going to be right here. So let us just recreate that now using our line system here. Yeah. So moving from here to here. Put that in green. Here to here. There it is. So you could see that everything is half, and that is what we're saying, that hey, when you have a scale factor of a half, and you are at when you have a scale factor that is a half, and any scale factor, the moment the center of the enlargement is 0, 0, you can manipulate the coordinates, and that's what we did here, taking a half of the object coordinates, and it produces the image. We were told to call this W. And you can see that it is really a half of everything. Like we could just do a quick check of this. These two corresponding sides like this. Check this out. That's going 1, 2, 3, 4, 5. That's 60 units long. And then the corresponding side for it, check it out. It's like 3 units long. So you can see everything was reduced just using that to show. All right. So basically that is question 3. Like, share, and subscribe to this channel, and look out for the other questions that are coming.